Hello, everyone. This is Rachel McIntosh. I'm Senior Manager for Customer Success at CoxEdge. I just want to welcome you guys to our monthly webinar series. This is where we explore and highlight what's new in Edge Cloud and Edge computing. This month, I'm excited to introduce you to Michael Ridley, the Senior Developer Advocate at Macrometa. Every day, Michael helps developers get the most of Macrometa's tech and helps to push it to its limits. And today, he's going to show us the latest ways to overcome slow speeds and improve poor user experiences. Last month, in our April webinar, we discussed speeding up dynamic content. However, most apps serve up a mixture of dynamic and static content. So this month, Michael will go over the 5 best practices and ways of thinking about performance and architecture so you guys can fix both kinds of speed issues. Hi, Michael. Welcome to the CoxEdge webinar series.
Hello, Rachel. Thank you so much for having me. It's great to be here. Did you want to go ahead and get started then?
Yep, for sure.
Okay, perfect. Thank you so much, Rachel. So appreciate that kind introduction. And as Rachel said, my name is Michael Ridley. I work for Macrometa, and we are a Edge Cloud company partnering with CoxEdge. So they're great partners for us. And today we are going to discuss 5 common reasons that cloud applications may run slowly. And so we're going to talk about infrastructure locality and why the cloud is too far away often, and how that plays into the cap tax, which you'll find out what that is if you don't already know. Rigid query engines often are a factor. It's not you, it's them. That's talking about how user behavior can be unexpected, and users can use your applications in ways you don't expect. And then API overload, and stay tuned to find out what that is. So infrastructure locality, and this really plays into the Edge Cloud story, which is that today's public cloud is really too far away. So often you're at least 100 milliseconds, maybe 250, 300 milliseconds from your data storage provider if you are using a traditional cloud. And often depends on the cloud data store, but for the most part, you're going to have a single region, at least that is your primary environment that you're writing to, and then it may replicate, but then the replication latency often is even more than just the latency to access the data locally or to write the data locally. And so when we talk about that, as we said, the global latency is over 100 milliseconds. And anytime you're reading or writing from a database, which any kind of mobile application, IoT, industrial, sensor, predictive maintenance, that, any of those kinds of applications, everything you're doing is a read and a write. And particularly when you talk about process automation and industrial applications like that, to the extent that you're going to run those in the cloud, you really can't tolerate that kind of latency. And so the trade-off that you have is often cost and performance, because with a traditional cloud database, to architect that in such a way that you're trying to overcome these limitations, you're going to have to set up a multi-writer application. Again, you really can't get over the latency, and it's just not, it doesn't really work. And so CDNs have been the answer since the birth of the web, really, or at least the birth of the commercial web, I guess. I don't know how big CDNs were when NSFNet was still a thing, but certainly since the mid-90s, CDNs have been the way to go for static web content and images, and often media as well now, video and other things. And that's great for static content. But the new class of applications, whether it's social networks, IoT, industrial, predictive maintenance, any of that sort of thing, those are dynamic. And so it's not just serving static web content. And so, what you really need is like a CDN for databases. And that's where a technology like Macrometa can help you, again, partnering with CoxEdge, where we can bring that ability to store and process dynamic data to the edge, much like you would do with a CDN, but for dynamic data with a latency of often under 10 milliseconds, which, again, that's a game changer if you're looking at traditional technologies where, it may be in the hundreds of milliseconds. So, and this really feeds into the cap tax, and this kind of makes it a little more concrete. So, the cap theorem, which is not something that we made up, it's a commonly discussed theorem in computer science, and so you can certainly go Google this and learn probably much more than you know today about it. Maybe unless you're an expert, I guess. But what it says in a nutshell is consistency, availability, and partition tolerance, and you have to pick two. And this again comes out of theoretical computer science, and it's the state of the art, right? Like there's not a data store that exists that can solve for all of these concurrently. And so that's again, it kind of goes into why does the infrastructure locality matter, and this is why, because you can't architect a system that overcomes it. So where that matters is when you talk about synchronous writes and eventual consistency. So eventual consistency is where you write once locally, but then when I say locally, I mean, to an edge point of presence perhaps, and then that data will replicate eventually to the rest of the data storage, and it will be consistent so that all readers will get the same version of the data when they read. But that does not you can have some inconsistent reads during the replication time, so you can't avoid it. But what you can do is you can alleviate the problem, you can mitigate it. And so there are modern data synchronization approaches such as CRDTs, which are what does that stand for? It's I just totally went blank. But effectively, what it is it's a conflict-free replication data type. That's what it stands for. And so again, to get into how that works and what that is exactly, is probably beyond the scope of this time that we have for this presentation today. But just know that there are some newer technologies that, again, CRDTs are not new in the theoretical computer science space. They've probably been around for maybe 10 years or so. But when you look at commercial implementations, it's more cutting edge in terms of its propagation out of academia and into commercially available solutions. And so Macrometa uses that. We're not the only ones, but we have a good we have a little bit of a different kind of an implementation. And if you want to know more about that, you can of course go to the Macrometa website, and we have a white paper that explains it. And so so cloud-based interactive applications can't wait for a stop the world synchronization. And I took the term stop the world from commonly what you hear about in garbage collected languages, in garbage collection, where for example, Java, the JVMs will do a stop the world garbage collection. But what I mean by that is basically when we need to synchronize, when we need to do a synchronous write, we have to just wait for it to propagate to the entire world. Again, that could be high hundreds of milliseconds. And for the modern generation of applications, you can't wait that long. It creates bad user experience. And for many classes of applications, you just can't do it. You just can't write them at all. So again, using a modern technology like CRDTs in the Macrometa platform can solve that for you, at least in terms of solve it for your application, right? It's not going to solve the underlying, it's not going to cheat the cap theorem, but it will make it so that you don't need to worry about it for your application. And again, you don't get that with centralized cloud data stores. So another thing that can cause slowness. So we've talked more about the infrastructure up until now, physical locations of data, that sort of thing. But there can be other architectural choices that you make in your cloud application. For example, rigid query engines. And so generally, when you pick a data store, there is a class of write operations that data store is performant for, and a class of read applications, and they may not be the same, or they may be the same, but maybe your application needs to write in one way and read in another in a performant way. That's common. And so, for example, if you have a key value store, what's kind of in the name, right? You have a key and a value. So if you want to query something, the way you query it is by knowing the key. But what if you don't know the key, right? What if you want to query by something that's in the value? Well, you're out of luck. It devolves into a full table scan. And so Now, it's not that there are no data stores in the world that have that. There are traditional relational databases, your Oracles, your MySQLs, your Sybase, whatever. Um, and so those do allow you to do secondary indexing on other columns, but you need to have a very rigid schema to do that, and sort of third normal form, or I don't know, in data warehousing, you have star schema, all that. But you need to have a very rigid schema, and depending on what database technology you're using, it may or may not serve, it may or may not do well with schema evolution. So for some class of applications, that's fine, but for others, it's not. And so then another solution to that could be natural language search, so traditional search engine. And that's great, but search indexes are not generally systems of record, and so that can be a limitation. So what so the real sort of modern answer to that is, well, you need something that can do all of it. You need a multimodal database like Macrometa. Again, kind of a theme here. I work for Macrometa, so I'm biased. But there are other solutions in the market. But you need a multimodal database like Macrometa that will allow you to read and write in different ways without having to readjust the data, reprocess the data. And so, for example, in the Macrometa database, we have document-based collections that you can then query as if it were a database with fields, but you can also do natural language, and it will keep the index updated. So although the index is not the system of record, it mirrors the system of record. And this is not the way that traditional data stores work. This is not the way traditional cloud data stores work. But when you're talking about performance in your cloud application, you need something that can sort of do both. And so multimodal database is what you're looking for. And then we talk about user behavior. And look, it's easy to knock users and say, well, they're doing the wrong thing. But look, we want users, right? I mean, all of us are out of jobs if people don't use our products. So it's not an us versus them thing. We love our users. We want our users. But sometimes they'll do things in ways that we don't expect, or ways that we didn't architect our infrastructure or our application to support. And so unexpected usage patterns, it may be that that your users are doing things in ways that you didn't expect. Or it may be that a certain feature of your application is very popular and you didn't expect that, right? You thought it would get not very much use. And so maybe it wasn't architected in as scalable of a way. So this is where telemetry and instrumentation can help you identify user behavior early. And this is a real key difference in the cloud versus traditional on-prem applications, because the legacy way of doing it would be to have error logs, and you sort of instrument your code with logging, and you write logs. And that's fine if your customers are running it in an on-prem environment and they're sending traditional support bundles to your customer service, customer success team. But that's not a cloud native way to do it. And in the cloud, what you want to do is you want to have instrumentation and then telemetry systems that will record everything that your users are doing and all of the usage patterns. And then you want to automatically analyze them and look for outliers, look for feature usage that you didn't expect, you even want to have profiling data in there so that you can see, oh, look, this API call is taking 3 seconds to return. That's not acceptable. Like, why? But you won't know if you don't build that kind of telemetry and instrumentation into your application. So it's really important. And then again, the answer is not like, oh, your user shouldn't do that. It's more of we need to invest more in that feature because we didn't know that it was going to be that popular. But it gives you a lot of insight into your product market fit as well. So the victim of your own success. This plays off the last one, but it's a little more general, which is, you may have an application that you thought would have 1,500 concurrent users, and for whatever reason, it has 15,000 concurrent users. And that's not bad. That's great. That's what we want, I would think. Certainly for any applications I can think about, we want to have a lot of users. But if you don't plan for it and you don't architect for it, then of course you can have all sorts of slowdowns and stability problems and everything else. And so, I used to work in consulting for distributed systems, and we would talk about scalability a lot. And the thing about scalability is it's not that you have 10,000 nodes day one, right? People talk about scalable infrastructure, scalable architecture, distributed computing. Yeah, maybe you do. Maybe you have 5 nodes day one, but the point of a scalable architecture is not the number of systems that you are running today. It's, can you linearly or close to linearly, or at least, in some manageable curve, scale up as your resource requirements grow. And so you want to architect that from day one. You want to start thinking before you even build your application, hey, what happens if we have 10x or 100x the number of users, or the number of, consumption of this feature, or whatever it is, than we're planning for in our product, design document, and architect for that, whether it's using a scalable cloud data store, or making sure that you have CDN partners in place, or whatever it is. And then user error. And, user error can be many things, but what I've seen often happens is you may have a performant and scalable way to do something in your application, but it's not apparent in the UX. And so what your users will end up doing, because they need to do whatever that usage pattern is they'll find another way to do it, but it may not be very performant. For example, maybe people need a natural language search capability, but they don't know that you have a natural language search engine in your product. And so instead they'll start sort of mashing that into SQL commands using, like statements or something, or R-like, and querying something in a SQL database using R-like is not going to be as performant as a purpose-built natural language search index. And so often that comes into designing for discoverability and a good UX. And so again, that's where the telemetry is very important, because if you see, oh, wow, people are doing a bunch of natural language searches in our SQL database, why are they not using our search index, where this would be 1,000 times faster? When you identify that usage pattern, then you can say, oh, because you know what, we should probably put the link to our search index on this page where people are running the SQL queries, or whatever. But again, it's I'm a big fan of, I love users. I work in developer advocacy, developer experience. I'm very much like, help me help you, right? Like, I want everyone to be successful. And so again, that's where the product can come in and say, oh, okay, we love that you're trying to do this. How can you do this in a way that's more performant and is going to work better on our platform? Then we talk about API overload. And so again, APIs are great, but external APIs can slow down your application. So in this cloud world that we live in, right, everything is an external service, everything is an API. And that's great, because we can integrate all kinds of data that we don't have natively. So, whether it's weather data or climate data or financial data or whatever it is, these are coming from third-party data providers often. And so your application may slow down as a result of factors that are totally out of your control. So what do you do about that? Well, one question is, what can be cached? And this can be a very slippery slope, because you may have agreements with your data providers that say you can't, or you can, but only for this amount of time, or who knows. So you will need to be cognizant of that and make sure that you're doing everything within the license of the data that that's compliant with the data's license. But it may be that there are things you can cache. Certainly for any sort of government or open source data source, you presumably can cache that. So that's a good thing to do. And it may be that you are using the cache as a backup. So you're going to hit the API, but if the API doesn't return in 20 milliseconds, you throw that away and you serve it out of the cache. Related to that, what can be called asynchronously? So maybe you don't need to stop the build of your web page or mobile app or whatever, but you don't need to have your UI not load until you have all the data. Maybe the weather data or the financial data is a nice to have, and it can enrich the experience, but it may not be fully required. Can you call that asynchronously, so that if it takes 3 seconds to load for some crazy reason, your users may notice, because they don't, that part of the screen still says loading, but it's not making the whole application not performant for them, and it doesn't reflect poorly, hopefully, on your brand if your third-party data providers are not having a fast day for whatever reason. And then the other question is, are you calling a free tier, right? So a lot of API providers, including Macrometa, have a forever free plan where you can use our platform with limited well, it's pretty much unlimited capabilities, but it's limited query volumes, limited storage volumes, and often that's a great way to get started prototyping and developing your MVP, your minimum viable product. But it's very common that you'll start sharing the link to the MVP, you'll get some growth, maybe you'll get some investment, and then you launch it, and no one ever remembered. Oh wait, we're using this third party API or this third party data provider that we're still on their free tier, and that has a rate limit throttling or something. Oh, maybe we should pay the whatever nominal amount of money we need to pay to get access to the performant version. And so, those kind of audits and being mindful of your architecture and being mindful of the touch points in your architecture is really important. So those are the 5 reasons that we're talking about today, where your cloud applications may be slower than you'd like them to be. And hopefully we gave you some food for thought on how to identify that and where to find those slowdowns and performance problems in your application, as well as some thoughts on how do you alleviate those problems and solve those solutions. So, of course, we would love for you to come to macrometa.com and learn more about our product. As I mentioned, we have a forever free account, as does Cox Edge as well has a free developer account, so you can take a look at that. And then you can also get some free usage credits for entrepreneurs and founders at Cox Edge. And the links for all of those are on the page. Again, macrometa.com, portal.coxedge.com/register, and coxedge.com/catalyst-startup. So thank you so much for coming out today. And again, hopefully we gave you some food for thought. Rachel, back to you.
Fantastic. Thank you, Michael. That was very interesting. We do have some questions that we got before we went live, and some other questions from the chat that I'd like to take a moment to get into. The first of which is there one thing you would most likely recommend that someone tackle first? And is there an 80-20 situation where doing one thing right helps prevent other issues down the road?
Yeah, I think this is where telemetry and instrumentation comes in, because if you it's very hard to identify any of the problems that we discussed today if you don't have the data that's going to show you those problems. So that's where I would focus first. If you have a complicated, sophisticated application that you've already built and you're getting sort of intermittent complaints from users, oh, this is slow, but then you go check it and it seems fine to you, or some users say it's really fast, some say it's really slow. Instrument it, put in the telemetry, and then you'll find, oh, maybe a certain set of our users in a certain geo, maybe there's some hardware problems with my cloud provider, or who knows, right? You don't know. So I would say the first thing to look at is getting the data, so that you can be a data-driven business, and then that'll help you identify, okay, great, where is the 80-20 split, and then you don't have to guess, you just go tackle it in the order that it makes sense.
Fantastic. That makes sense. But what if they've already built an app that's fallen into one of these architectural traps? How do they address that?
Sure. Yeah, absolutely. I mean, again, most of us are not starting from zero, or I mean, if you are, that's great. But I'm sure not everybody listening is starting from zero. So this is where, again, I would go back and I would step one is instrument it so that you can understand where your slow spots are, where your hot spots are, and then what you want to do is identify those 80% and focus on those. And a good design pattern is modularity or even a service-oriented architecture. And so depending on how your application is architected, you can address those piece by piece, component by component. And the other thing is, it may be that the technologies that we're talking about today can work very much in concert with traditional cloud data stores. So you don't need to pull everything out. You may be able to use the edge as a caching layer and still, for some period of time, use your traditional cloud native data store as a data warehouse, or as an aggregation data store for BI reporting or whatever. And that way you don't need to rewrite all of those applications day one. You can just leverage the edge for the parts that are going to really give you the bang for the buck on your user experience. And the rest of it you can change later or not.
Fantastic. That makes sense. Let's see. Oh, another good question. Do you believe that the user would have to abandon their existing infrastructure and architectural investment to speed up an application?
Yeah, so that kind of goes into I think I kind of saw that question out of the corner of my eye, and my brain sort of started almost like pre-answering that. But no, you don't, right? It's not realistic that you're gonna say, oh, let me throw everything away. Um, no, this is where again the edge cloud will work in concert with your traditional cloud providers so that you can leverage the edge where it makes sense. And there may be other things where, if you have I don't know, very large data sets that you want to aggregate and do distributed computing with something like Spark, or whatever, that may be a great use for a traditional cloud. And so you can sort of mix and match.
Okay. And where do CDNs fit into all of that?
Yeah, for sure. So CDNs are critical, right? And CDNs are in many ways step one of the edge cloud, or sort of the original edge cloud, because they are taking your centralized static data and distributing it around the world or wherever you're telling them to distribute it, and in making it performant for your end users to query and access and retrieve that data. The problem with CDNs, or the limit with CDNs, not really a problem, but the limitation with CDNs is that they're for static data. So they're great for images, they're great for videos, they're great for static web pages, but they don't really address things like, oh, I have IoT sensor data coming in that says the temperature sensor on this manufacturing process is 7,000,000 degrees. What should we do about that? Like, you can't put that business logic at the edge in a CDN, but you can in an edge cloud like with Macrometa and Cox Edge.
Fantastic. Fantastic. Oh, it looks like we have another question from Arvin
Hmm.
in the chat. With telemetry, what is the use case for Macrometa and how is Macrometa different from APM?
That's a really good question. I don't know what does APM stand for? I should Google that real quick.
Arvin?
Yeah, Arvin, can you tell me what application performance management? I see. Okay, I Googled it. So Arvin, I'm assuming that by APM, you mean application performance management, which I'm an expert in because I just Googled it. No, okay, so it's different. It's very different actually. And so if that's not clear, let me let me explain, because they're very different things. So Macrometa is not an APM platform. So when we talk about application performance management, there are many um, companies out there in the world that will take your log data or any other kind of data you send them and do this kind of performance analysis that we're talking about. You would use one of those potentially if you wanted to with something like a Macrometa. But Macrometa is a data store. So we are a multimodal NoSQL database. So we would be potentially the system of record for your application, right? We would be like, if you're building a social network, for example, that was very performant for whatever reason, we would store your user data, right? We would store your application data, and as well as do business logic through things like our stream workers, which is our stream processing framework, where you can do arbitrary business logic on data in motion, or query workers, which you could sort of think like stored procedures, where you basically push the business logic to the database, and then you have your query logic, or your presentation logic or your BI logic independent of that, so that you can manage those two sets of logic separately. But Macrometa would be a database. You could think of us as a data store, sort of like a DynamoDB, or like a Azure Cosmos or a Redshift or something like that. So we would be very much the data store for your application. Could you store application performance information in there? Of course you can. But you also might send the telemetry that we've been talking about off to something like a New Relic, or similar product to that. So they're kind of different.
Fantastic. Fantastic. Looks like we're pushing right up against the 30 minutes, and we
Yep.
always try to stay within the time promised. Thank you, Michael, for joining us this month, and thank you everyone for joining as well. Again, like Michael said previously, on the screen, you'll see the QR code and links to our website. You can get a free Cox Edge trial, and also the link for more in-depth demo and discussions with Macrometa about their product. Thanks again, everyone, for joining us, and we'll see you next month.
Thanks, Rachel.
Thank you.